in this calm night atmosphere. Welcome to the Night Library. I would love to know from which corner of the world you are watching and what time it is there right now. Here in this Library of the Night, we bring you documentaries on science, history, and philosophy, crafted to soothe your mind and gently guide you into deep, restful sleep. Tonight, as you rest under the silence of the stars, we will journey together through mysteries of the universe, not with haste, but with calm wonder. Every chapter will open a new door to science, history, and philosophy, gently guiding your mind toward sleep. So, take a deep breath, let your body grow heavy, and allow your imagination to drift. Because here, in the Night Library, every word is a lantern, glowing softly in the dark, leading you through the vast corridors of knowledge until dreams carry you away. Chapter 1. Silent Beginning. Where does space end? Where does space end? At first, the question seems childlike, almost naive. You might remember whispering it when you were young, lying under the stars, staring up into the endless night. If I kept traveling further and further, would I one day reach the edge? And if there is an edge, what lies beyond it? This question has lived with us for centuries. Philosophers, dreamers, scientists, all have asked it in their own way. And though we live in an age of powerful telescopes and mathematical theories, the mystery still lingers. The deeper we look, the more space stretches before us, teasing us with its silence. So, let us begin, slowly, calmly, drifting into the darkness of the question itself. The human longing for edges. Why do we ask where space ends? Perhaps because our entire life is bounded. We live inside rooms, we walk through doors, we cross over rivers, climb over mountains. Every part of our daily world has an edge, a boundary, a place where something ends and something else begins. When we look up at the sky, however, it feels different. It does not seem to stop. There is no wall, no border, only depth upon depth of darkness and distant lights. And because we are human, we search for edges. We want to know, where does it stop? Ancient civilizations answered this longing with stories. The Babylonians imagined the heavens as a great dome, solid and strong, painted with stars, resting on cosmic waters. The Norse spoke of Yggdrasil, the world tree, whose branches held countless realms. The Greeks believed that the stars were fixed upon a crystal sphere, spinning around the earth. These myths were not foolishness. They were comfort. They gave shape to the unknown. They told us, yes, there is an edge. Yes, the cosmos is held in order. Yes, it is safe. But the truth, the real truth, is far stranger. The first scientific skies. For millennia, the stars were points of light that never seemed to change, but slowly people noticed patterns. The wandering stars, planets, traced paths across the heavens. The moon swelled and faded with rhythm. The sun rose and set with clockwork precision. This was not chaos, this was law. From this realization came a daring thought. If the cosmos has laws, then perhaps it also has size, structure, shape. Is it finite or infinite? Philosophers debated. Aristotle declared that the universe was finite, a perfect sphere bounded by the stars. Centuries later, Giordano Bruno imagined endless worlds, an infinite universe, stretching without end. His vision was so dangerous to the order of his time that he was executed. Yet today we see echoes of his dream in our telescopes. Standing at the edge of infinity. Imagine yourself as an ancient sailor. You push your ship into uncharted seas. The horizon is endless. The waters stretch beyond sight. Once, people feared that sailing too far would bring you to the edge of the world, where you might tumble into nothingness. But instead, the earth revealed itself to be round. Travel far enough, and you simply return to where you started. Could the universe be the same? Could space curve back on itself, so that if you traveled in one direction long enough, you would return to your starting point? Not because you hit a wall, but because there was never a wall at all. Or perhaps the universe is infinite, unending, without borders, without a final stop. If so, then no matter how far you travel, there will always be more. Infinity upon infinity, without edge, without limit. Both possibilities, a curved universe or an infinite one, are staggering. Both stretch the imagination beyond comfort. And here, we must pause, because before we ask where space ends, we must ask what we can see. What lies before us is not the whole universe, but the observable universe. It is like standing in the fog. The world continues beyond, but your sight ends where the mist thickens. Our observable universe has a radius of about 46.5 billion light years. That makes it roughly 93 billion light years across. This is the bubble of light that has reached us since the beginning of time. Since the Big Bang, nearly 13.8 billion years ago. Does that mean the universe ends at 93 billion light years? No. It only means that this is the farthest light has traveled to greet us. Beyond it, more may exist. Galaxies, stars, clusters. But we cannot see them. Not yet. Perhaps not ever. So we live inside a bubble of sight, a cosmic horizon, an edge, not of reality, but of perception. The edge that isn't an edge. This horizon is not a wall. You will not crash into it with a spaceship. It is not a boundary of stone or steel. It is simply the point where light has not yet arrived. And here lies the mystery. The universe may go on beyond this horizon. It may be infinite. Or it may curve back on itself. Or perhaps it holds structures and dimensions we cannot yet imagine. We do not know. And maybe we never will. But in this not knowing lies something beautiful. The universe is not a solved puzzle. It is an unfolding story. The whisper of infinity. Close your eyes again. Imagine walking to the edge of space. Imagine stepping into the silence, walking past galaxies, past stars, past light itself. You walk and walk, but the edge never arrives. Does that mean there is none? Or does it mean that the edge is simply beyond your sight? Infinity whispers softly. It does not shout. It tells us that some mysteries are not walls to be broken, but oceans to be sailed. A gentle conclusion. So, where does space end? Perhaps nowhere. Perhaps everywhere. Perhaps the question itself is the answer. We are meant not to find the edge, but to feel the wonder of searching for it. To live inside a mystery so vast, it humbles us, comforts us, and reminds us that we are part of something far greater than our small lives.
In our last chapter, we asked, where does space end? We wandered through the silence of infinity and stood at the edge of the observable universe. Now, in this new chapter, we step closer to the minds who shaped our first real picture of the cosmos. And at the heart of that picture stands a single man, Isaac Newton. The stage is set. Imagine a theater. The curtains are drawn back, the lights shine down upon it, scenes unfold upon it. The stage itself does not move. It does not change. It simply holds the drama. This was Newton's universe. To him, space was the stage. Absolute, unchanging, eternal. A background against which all events played out. Planets orbited, apples fell, oceans rose and fell with the tides, but the stage remained the same. And alongside space was time, ticking steadily, unbroken, the great clock of the universe. Every second identical, every moment marching in step with the last. For everyone, everywhere. This was Newton's vision, a cosmos built upon certainty. To understand why Newton's view mattered, we must step into his time. The 17th century was an age of turmoil. Europe had seen wars, plagues, and political upheaval. Religion and philosophy argued bitterly over the nature of reality. And yet, in this storm, Newton offered something astonishing: order. He revealed a universe that was not chaotic, but lawful. The apple falls not by magic, but by gravity. The planets orbit not by whim, but by mathematics. For the first time, the heavens and the earth obeyed the same rules. This was a comfort. It told people the universe is rational, predictable, safe. If you know the laws, you can predict the future. You can chart the stars, build machines, sail the seas with precision. Newton's space and time were the firm floor beneath the dance of reality. But what does it mean to say that space is absolute? For Newton, space existed independently of the things inside it. Even if there were no stars, no planets, no matter at all, space would still exist. Vast, empty, eternal. Like a silent stage awaiting actors who may or may not appear. And because space was absolute, it provided a fixed frame. Motion could be measured against it. If you were moving or at rest, space itself knew the difference. Like the background grid of a great cosmic map, always there, always steady. Time, too, was absolute. It flowed at the same rate for everyone, everywhere. Imagine a clock whose ticking could be heard by the entire cosmos, keeping perfect rhythm. 1 second for you was 1 second for me, was 1 second for a star in a distant galaxy. This view made reality dependable. The past was fixed, the future was calculable, the present ticked forward like gears in a watch. The clockwork universe was breathtaking. It replaced the uncertainty of myth with the clarity of mathematics. It gave birth to modern science, to engineering, to the Industrial Revolution. Humanity felt for the first time that it could truly understand the cosmos. Yet Newton's absolute space and time were not just science, they were philosophy. They told us that reality has a foundation, that beneath all change there is something unchanging. This offered comfort. People long for stability. In a world of storms, Newton gave them a floor of stone, a stage that would never collapse, a time that would never falter. But this comfort carried weight. For if space and time are absolute, then they are also separate from us, unfeeling, unchanging, indifferent. The universe became a machine, precise but cold. The challenges began. Not everyone agreed. Even in Newton's time, some questioned his vision. The philosopher Leibniz argued that space was not a thing in itself, but a relationship between objects. Without stars and planets, there is no space, just as without actors, there is no play. These arguments simmered for centuries, but Newton's picture was so powerful, so useful, that it endured. For more than 200 years, it shaped how humanity saw reality. The limit of absolutes. Newton's space and time worked beautifully until they didn't. As scientists peered deeper into the universe, as they measured light, motion, and energy, cracks began to appear. If time is absolute, Why do observers moving at different speeds measure it differently? If space is fixed, why does light behave as if space itself can bend? Newton's certainty began to blur. The stage was not so solid after all. The great cosmic clock ticked with strange rhythms. And it would take another genius, with wild hair and chalk-stained fingers, to show us a new vision. Albert Einstein would reveal that space is not rigid, but flexible, not absolute, but woven with time into a single fabric. But that is the next chapter of our journey.
Chapter 3. Einstein's Fabric. The magical picture of space-time. A man with untidy hair. Imagine a man walking down a quiet street in early 20th century Europe. His hair is unruly, his coat a little too big, his pockets filled with scraps of paper and chalk dust. His mind, however, is a galaxy of ideas. Albert Einstein was not like other scientists of his time. He was a dreamer, a poet of physics, someone who questioned even the most obvious truths. To him, the certainty of Newton's space and time was not comfort, but a puzzle. He asked, what if the stage itself can move? What if time itself is not absolute? And from those questions, he built a new picture of the cosmos, stranger, more beautiful, more unsettling than anything before. The fabric of reality. Einstein told us, space is not a rigid box. Time is not a steady river. Together, they are a single entity, space-time. Picture a sheet of fabric stretched tightly across a frame. This is space-time. Now, place a heavy ball in the center. The fabric dips. Place a smaller ball nearby. It rolls toward the dip, not because the large ball pulls it, but because the fabric itself has curved. This was Einstein's revelation. Gravity is not a force, it is geometry. The Earth does not pull us down like a magnet. Instead, it curves the space-time beneath us, and we simply follow the curves. The Moon does not orbit the Earth because of an invisible tug, but because it is forever falling along the curved paths of space-time. The stage itself, once thought unchanging, is alive. Time joins the dance. But Einstein went further. Not only space bends, time bends as well. Imagine two clocks, one on Earth, one far away in the depths of space. To Newton, they tick in perfect unison. To Einstein, they may not. The closer a clock is to mass, to curved space-time, the slower it runs. Time itself stretches and compresses like an elastic thread. This is not imagination. Astronauts in orbit, satellites around Earth, even your GPS system, they all experience these shifts in time. Without Einstein's corrections, your phone would place you miles from where you truly stand. Time is not absolute. It flows differently depending on where you are, how fast you move, how curved the space-time beneath you becomes. The poetry of bending. What does it mean to live in a universe where space and time bend? It means the cosmos is not a cold stage, but a living fabric. It hums with the weight of stars, stretches under galaxies, ripples when massive objects move. Imagine tossing a stone into a pond. Waves spread outward. Now imagine two black holes colliding in the far reaches of space. The ripples spread across space-time itself, gravitational waves whispering through the universe. And one quiet morning in 2015, humanity heard them for the first time. Sensitive detectors buried on Earth recorded the faint tremor of space-time. Einstein's dream had rippled into reality. The human reaction. At first, Einstein's ideas were met with disbelief. Scientists clung to Newton's clockwork. They found safety in absolutes. Einstein's bending space-time felt too strange. But slowly, experiment after experiment proved him right. The starlight that bent around the sun during an eclipse, the slowing of clocks near Earth's surface, the predictions that matched reality with uncanny precision. Einstein was not rewriting physics. He was rewriting the stage of existence. A universe alive. Think of it. We live not on a stage, but in a fabric. We do not move across empty space, but along curves woven by stars and galaxies. We do not experience time as a single river, but as countless streams flowing at different speeds depending on where we stand. Reality is not absolute. It is relative, dependent, interwoven. This is Einstein's gift and his challenge. For if space and time themselves can bend, what is left that is eternal? The comfort and the fear. There is a strange comfort in Einstein's vision. It tells us we are part of the dance. We are not standing on a distant floor, separate from the cosmos. We are woven into the same fabric as the stars. Our lives are threads in space-time's cloth. And yet, there is fear too. For absolutes vanish, certainty dissolves. There is no universal now, no shared ticking of the clock. The universe is more alive, but also more slippery, more elusive. Toward the next horizon.
Chapter 4. The Secret of Empty Space. The Dance of Quantum Fields. The Illusion of Nothingness. Close your eyes. Imagine drifting away from Earth, past the moon, past the planets, into the dark gulf between the stars. You look around. No planets, no dust, no starlight. Just silence. It feels like nothing. For centuries, humans believed exactly this, that space was a void, a vast empty container holding the stars and galaxies. Newton himself described it as absolute emptiness, a stage without actors. But the closer we look, the stranger the truth becomes. What we call nothing is not nothing at all. It is alive, restless, trembling with invisible motion. The Quantum Whisper. In the 20th century, scientists uncovered a new language of the cosmos, quantum mechanics. And quantum mechanics whispered a secret. The vacuum, the empty space, is not silent. At the smallest scales, smaller than atoms, smaller than particles themselves, space is woven with quantum fields. These fields are the foundations of reality. Every electron, every photon, every quark is born from them. Even when no particles are present, the fields remain, humming faintly, like the strings of an instrument vibrating in silence. The flicker of phantom particles. Imagine looking closely at empty space with a magical lens. What would you see? You'd see tiny sparks flickering in and out, pairs of particles appearing for a heartbeat, then vanishing again. These are virtual particles, quantum guests that never stay. They cannot be captured, yet their presence leaves fingerprints. They shift the behavior of electrons around atoms. They alter the forces between particles. The vacuum, then, is like a restless ocean. From the shore, it seems calm. But if you dive beneath the surface, you find waves, currents, and schools of fish darting in and out of view. Vacuum energy. This hidden motion has a name: vacuum energy. Even the emptiest corner of the cosmos holds energy, trembling just below awareness. It is as though the universe refuses to ever be still. The fields cannot stay quiet. They ripple, they stir, they breathe. This realization shook physics. Emptiness was supposed to be nothing, yet here it was, overflowing with invisible life. The cosmic implications. What does this mean for us, sitting here in the night library? It means the universe itself is never at rest. Even in the darkest void, something stirs. Some scientists believe this vacuum energy may be tied to dark energy, the mysterious force pushing the universe to expand faster and faster. Imagine the very hum of empty space multiplied across the cosmos, stretching the fabric of space-time outward. If true, then emptiness is not just alive, it is powerful enough to shape the destiny of the universe. The philosophy of nothing. Pause for a moment. What does it mean that nothing is never nothing? That silence always hides a song? For philosophers, this is profound. It means existence cannot be reduced to absence. The void is not a barren desert, but a hidden garden. To say there is nothing is already untrue. There is always the whisper of being. The gentle metaphor. Think of a quiet fireplace late at night. From far away, it seems to have gone out. The flames are gone. The wood is ash. Yet if you look closer, you see embers glowing, faint, red, alive. Blow gently, and they flare back to fire. The vacuum is like that, an ember of the cosmos, glowing even in darkness, ready to spark with particles, waves, and fields.
Chapter 5. An Expanding Universe. Raisins in the Bread. The ancient assumption. For most of human history, people thought the universe was eternal and unchanging. The stars above seemed fixed. The constellations returned year after year. To shepherds, farmers, and sailors, the sky was the one reliable map, a dome that never altered. It was comforting. Amid the chaos of life, the heavens remained the same. Surely the universe itself was steady, unshifting, forever. But as telescopes grew sharper, the truth began to whisper. The cosmos is not still. It is moving. It is stretching. Hubble's revelation. In the early 20th century, Edwin Hubble peered through his telescope at distant galaxies. What he saw changed everything. The light from those galaxies was shifted toward the red end of the spectrum. This red shift meant they were moving away. And not just one or two, nearly all distant galaxies were retreating. The farther away galaxy was, the faster it moved. This was not random. It was a pattern, a cosmic law. The universe itself was expanding, stretching like dough rising in an oven. The raisin bread analogy. Imagine a loaf of bread filled with raisins. As it bakes, the dough swells. Every raisin moves away from every other raisin
not because the raisins themselves are running, but because the dough itself expands. This is our universe. Galaxies are raisins. Space itself is the dough. When we look at the night sky, we are not watching galaxies drift through emptiness. We are watching the fabric of reality stretch between them. The meaning of expansion. This expansion changes everything. It means the universe once was smaller, denser, hotter. Trace the expansion backward, and you arrive at a beginning, the Big Bang. It also means there is no center. Every galaxy sees itself as the middle of the expansion. Just as every raisin sees other raisins moving away, so too does every galaxy see the universe receding from its perspective. There is no privileged point, no throne at the heart of creation. Expansion is everywhere, all at once. The fate of light. Expansion does not only move galaxies apart, it stretches light itself. Photons traveling through space are pulled like taffy. Their wavelengths grow longer, redder, weaker. This is why ancient galaxies appeared not only far away, but faint and red. Their light has been traveling for billions of years, stretched thin by the swelling of the cosmos. It is a reminder, space is not passive. It shapes even the beams of starlight that guide us. The philosophy of motion. Pause here in the night library and consider the strangeness. We live in a universe that is never still. At every moment, the distances between galaxies grow. The cosmos is not a frozen picture, but a film that is always playing, a melody always rising. What does it mean to live in such a universe? It means change is woven into the fabric of existence. Nothing is fixed. Not stars, not time, not even the emptiness between. To exist is to expand. The acceleration mystery. And yet the story grows stranger. In the late 20th century, astronomers discovered the expansion is not slowing down, it is speeding up. Something, we call it dark energy, is pushing the universe apart faster and faster. Like a fire beneath the dough, fueling the swelling. What is dark energy? We do not know. It may be tied to the restless hum of the vacuum itself. It may be something else entirely, something beyond imagination. But its effect is certain. Galaxies far away will one day slip beyond our view forever, carried away faster than light can reach us. The universe is expanding into mystery. The human heart. What are we to make of this? On one hand, it is frightening. The night sky is drifting from us, stars sliding into silence. One day, the heavens will grow emptier, darker. And yet, there is wonder. We live in a universe that grows, a cosmos not finished but unfolding. Every second, new space is born. Every moment, reality itself becomes larger. We are not trapped in a static prison. We are part of a living and expanding story.
Chapter 6. The Observable Universe, Our Cosmic Bubble. The Horizon of Vision. Imagine standing on the shore of a vast ocean. The water stretches endlessly, but your eyes only reach so far. The horizon curves, the sea disappears into blue mist. You know the ocean continues, yet you cannot see it. This is how we live in the universe. The observable cosmos is our horizon.
the farthest edge of what light has had time to bring us. Beyond it more may lie, but the mist of time hides it from our gaze. Light's long journey. To understand this cosmic bubble, we must remember how light works. Light travels, but not instantly. It takes time, a second to bounce from the moon, 8 minutes to reach us from the sun, 4 years from Alpha Centauri, our nearest star. Now stretch your mind. Some of the galaxies we see tonight sent their light billions of years ago. When the first humans carved symbols in caves, photons were already on their way. When Earth itself was only a newborn planet, some of those same photons were racing toward us. Tonight they arrive. Each star we see is not just a point of light, it is a time capsule. The 93 billion light-year bubble. Astronomers have measured it carefully. The observable universe has a radius of about 46.5 billion light-years. That makes it nearly 93 billion light-years across. Pause for a moment. The universe is only 13.8 billion years old. So how can we see farther than 13.8 billion light-years? The answer lies in expansion. While light was traveling toward us, space itself stretched, carrying its origin points further away. So the bubble is not just a snapshot of time, it is a moving boundary, shaped by light and expansion together. The illusion of an edge. It is tempting to think of this bubble as a wall, a sphere enclosing us, but it is not a prison, it is only a horizon. If you could leap to a galaxy on the far edge and look from there, your bubble would be different. You would see your own horizon, your own sphere of light. Everywhere in the universe, each observer is at the center of their own observable cosmos. Countless overlapping bubbles, like soap suds in a cosmic bath, each glowing with light. The edge is not the universe's edge, it is the edge of our sight. The humbling scale. Inside this bubble, astronomers estimate lie about 2 trillion galaxies. Each galaxy holds millions, sometimes trillions of stars. Many of those stars have planets. Some of those planets may have life. It is a staggering thought. 2 trillion galaxies, inside only the part we can see. Beyond the horizon, we do not know. Perhaps infinitely more. Perhaps something stranger. And here we are, a tiny species on a tiny planet, orbiting a modest star. The scale humbles us, and yet it is our home. The disappearing stars. There is a melancholy hidden in this beauty. Because the universe is expanding and accelerating, some galaxies are already slipping away. Their light, sent today, will never reach us. They recede faster than light can close the gap. This means that in the deep future, our night sky will grow emptier. Galaxies will vanish from view, not because they die, but because the expanding cosmos carries them beyond our horizon. The observable universe shrinks, even as the true universe expands. The philosophy of horizons. What does it mean to live inside a bubble of sight? It means that knowledge itself has limits. No matter how powerful our telescopes, no matter how sharp our equations, there is a boundary we cannot cross. Beyond it lies silence. But perhaps this is a gift. For limits keep wonder alive. If we could see everything, mystery would die. But with horizons, the universe whispers, there is always more, always beyond. The poetry of bubbles. Picture yourself lying beneath the stars. Imagine the bubble of light surrounding you, glowing faintly like a fragile soap bubble stretched across the void. You are at its center. Every living being, every civilization, every star in sight exists inside this bubble. Now imagine trillions of other bubbles, each centered on another star, another world, another consciousness, each overlapping, each expanding. The observable universe is not just science, it is poetry, a reminder that perspective shapes reality.
Chapter 7. The Cosmic Horizon. Beyond the Limits of Time and Light. The idea of a horizon. We all know horizons. When you stand at the shore and gaze across the sea, there is a line where the water meets the sky. Sailors of old feared that beyond it the world might end. Today, we know it is not the edge, only the limit of our sight. The cosmic horizon is the same. It is not the end of the universe, but the limit of what light has had time to bring us. Beyond it, more may exist, but its signals have not yet arrived. Why light matters. Why does light define our horizon? Because light is our messenger. Every star, every galaxy, every planet we see, we know them because light has crossed the dark to reach our eyes. But light, though fast, is not instant. It travels at 300,000 kilometers per second. Across small distances, this feels immediate. But across the gulfs of the cosmos, even light needs time. Billions of years of time. So our horizon is drawn not by walls, but by clocks, by how long light has been traveling since the universe began. The expanding trap. Here lies the twist. While light travels toward us, space itself expands. Imagine trying to walk across a room while the floor stretches beneath your feet. The more you walk, the more the destination slips away. This is why galaxies can recede from us faster than light itself. Not because they break the cosmic speed limit, but because the fabric between us grows. Their light, sent today, will never reach us. They fall beyond the horizon, carried away by expansion. This has a quiet sadness. Each night sky is not forever. Over cosmic time, more and more galaxies will drift beyond our reach. Their light will fade, their presence will vanish. Future astronomers, billions of years from now, may look up and see only our local cluster, a small island of stars adrift in silence. The cosmic horizon is not only about what we can see, it is about what we will lose. The edge of time. Think of it another way. The cosmic horizon is not just a distance, it is a time. The farthest light we see began its journey almost 13.8 billion years ago. Anything beyond has not yet had time to speak to us. It is like listening at a doorway. You hear voices from the next room, but the conversations farther away are still too faint to reach you. One day they might, or perhaps, if expansion is too fast, they never will. The philosophy of boundaries. What does it mean to live in such a universe? To know that what we see is only a fraction, that beyond our horizon lie realms forever hidden. It humbles us. It tells us that reality is bigger than proof, larger than vision. It suggests that mystery is not an exception, but the rule. And perhaps it offers comfort. For even if we cannot see beyond the horizon, we can imagine, we can dream of galaxies uncounted, of stars never to shine in our sky, of worlds that exist without ever touching us.
Chapter 8. Light. A time capsule. The nature of light. Close your eyes and imagine a star shining. Its glow leaves the surface, racing into the dark. It moves faster than anything else can, 300,000 kilometers every second. Yet even at such speed,
The universe is so vast that light must labor for billions of years to cross it. This makes light a storyteller. Every beam that touches us tells of where it has been, of the star that birthed it, of the age when it first began its journey. When you look at the night sky, you are not seeing the present, you are seeing the past. The time machine above us. Think of the moon. Its light takes a single second to reach us. When you see it 1 second ago. The sun's light, 8 minutes old. The nearest star beyond the sun, Alpha Centauri, 4 years old. Now stretch further. Some galaxies are so distant, their light began its journey billions of years ago, when Earth was only dust, when oceans had not yet formed, when no eyes existed to see. And yet the light kept traveling until it arrived, tonight, for you. Every star, every galaxy above is a time capsule, a memory written in photons. The look-back time. Astronomers call this look-back time. The farther we look, the older the light. At 1 billion light years away, we see galaxies as they were 1 billion years ago. At 10 billion, as they were 10 billion years ago. With every photon, we look deeper into the past. And so, telescopes become time machines. They do not show us the universe as it is, but as it was. The present is always hidden. We live surrounded by echoes. The ancient photons. Some of the light we catch tonight began its journey when Earth was young. Some began before Earth even existed. Imagine that. Photons launched from stars long before our planet formed, waiting patiently across billions of years to land on your eye, your telescope, your camera. They have seen ages come and go. They are survivors of time. Each one carries a memory of creation. But light does not always arrive unchanged. The expansion of space stretches it, pulling its waves longer, redder. This redshift means that not only do we see into the past, we see the past distorted by the swelling of the cosmos. Ancient galaxies appear faint, stretched, tinted. Their story is not told plainly, but through a veil of expansion. Still, we decode it. Astronomers measure the redshift and reconstruct the story. They use the fading colors of light as clues to the speed, distance, and age of galaxies. Light is not only a time capsule, it is a cosmic code. And then there is the oldest light of all, the cosmic microwave background. This faint glow fills the universe. It is the afterglow of the Big Bang itself, released when the cosmos was only 380,000 years old. It has traveled for nearly 14 billion years, stretched by expansion into microwaves, detectable only with sensitive instruments. When we map it, we see the baby picture of the universe, tiny ripples of temperature that grew into galaxies, stars, planets, and us. This is light at its most ancient, carrying the memory of creation itself. The philosophy of light. Pause here and think about this. To see is to remember. To look at the sky is to peer into the past. There is no present vision of the cosmos, only history, only echoes. Light makes us historians of the universe. It tells us that nothing is instant. Every perception is a delay, a postcard from what has already passed. Even the reflection in a mirror is a fraction of a second old. Every face you see is already a memory.
Chapter 9. Redshift, the scarlet journey of light. The nature of wavelengths.
Light is not just brightness, it is a wave, rippling like the surface of water. Some waves are short, blue, violet, carrying higher energy. Some are long, red, orange, carrying less. And just as the pitch of a sound can rise or fall, so too can the wavelength of light stretch or compress. The familiar analogy, the siren. Imagine standing on a street corner. A siren approaches, its pitch is high. As it passes and moves away, the pitch drops lower. The sound waves stretch because the source is retreating. This is the Doppler effect, and light, though faster, follows the same principle. When a star or galaxy moves away, its light stretches. Blue becomes red. Waves grow longer. Hubble's discovery again. When Edwin Hubble measured the light of galaxies, he noticed this shift. Nearly all galaxies showed redshift. Nearly all were moving away. And the farther they were, the stronger the redshift. This was the evidence that space itself expands. The redness of galaxies is not just color, it is proof of motion, proof of a living, stretching universe. Cosmic redshift versus Doppler shift. But there is a subtle beauty here. With galaxies, it is not just that they move through space, it is that space itself expands. The light traveling across it is stretched like ink drawn across parchment. So cosmic redshift is not just motion, it is the fabric of reality itself pulling light longer. The scale of stretching. Think of a photon leaving a distant galaxy billions of years ago. It began as bright blue, short and sharp. But as it traveled, space expanded beneath it. The waves stretched, lengthened, softened into red. By the time it reaches your eye, it is not the same photon that left. It is older, weaker, redder. It has carried not only a memory of its star, but a memory of the universe's growth. Redshift as a clock. Astronomers use redshift as a timepiece. The more stretched the light, the longer it has traveled, the ancient its origin. Redshift becomes a ruler of history. With it, scientists can map how fast the universe expands. They can measure its age. They can even glimpse the hidden hand of dark energy, pushing galaxies faster apart. But the limit of sight. At extreme distances, galaxies are redshifted so much their light slips beyond visible, into infrared, into microwave. To human eyes, they vanish. Even our greatest telescopes struggle. The farther we look, the redder the light, until it blends with the afterglow of the Big Bang itself. The scarlet journey of light is both a bridge and a veil. The philosophy of fading colors. Here, pause and consider the poetry. Every star you see above you is not just shining, it is shifting. Its light drifts slowly to the red, a reminder that nothing stands still. The universe itself paints in longer strokes, stretching the colors of creation. The night sky is not permanent. It is a canvas that fades, a picture that stretches as we watch. And yet in this fading lies truth. Redshift tells us where we came from, where we are,
Chapter
and
10,
where we are
a
going.
gentle ending, wrapped in the fabric of the cosmos. The circle of wonder. Think of how it began, with a simple question: where does space end? At first, it seemed like a child's question, almost playful. Yet it opened into an ocean. With every answer came more questions. With every horizon came another beyond it. This is the circle of wonder. The more we learn, the larger the mystery becomes. Like walking toward the horizon, you never arrive because the horizon always recedes. But perhaps that is the point. The purpose of the question is not to end mystery, but to keep it alive. The human place. What are we then in this story? We are small, yes, a species on a pale blue dot, drifting among 2 trillion galaxies inside a bubble of sight. Our lives are brief sparks compared to the ages light travels. And yet, we are also extraordinary. Out of all the countless atoms, stars, and galaxies, we are the part of the universe that looks back at itself. Through our eyes, the cosmos sees its own light. Through our questions, it hears its own silence. We are not outside the story. We are woven into it. The fabric as a lullaby. So tonight, imagine space-time itself as a blanket, soft and vast, wrapping around you. The same fabric that bends beneath Earth's weight, that stretches between galaxies, also cradles you. You are not apart from it. You are a thread in its weave. The ticking of your heart is a rhythm of time. The ground beneath you is a curve of space. You are part of the fabric, always have been, always will be. The gentle future. What will happen to the universe? Perhaps it will expand forever, stars drifting into silence. Perhaps it will collapse back upon itself. Perhaps something stranger still, beyond our imagining. But for now, it is enough to know that we live in the middle of its story. Not at its beginning, not at its end, but in its ongoing chapter. A chapter where galaxies still shine, stars still form, and questions still echo. The universe is not finished, and neither are we. The comfort of unknowing. There is comfort in not knowing, comfort in mystery. For if all were explained, there would be no room for wonder, no space for dreams. When you look at the stars, you are not meant to solve them like puzzles. You are meant to feel their silence, their beauty, their distance, and let your heart expand with them. The Night Library is built not of answers, but of questions. So now, as the chapter closes, let the journey settle softly in your mind. Remember Newton's stage, Einstein's fabric, the hum of emptiness, the expansion of galaxies, the horizons of light, the red shift of stars. Let it all become a lullaby, a slow drifting into rest. The universe does not end tonight. It stretches on, endlessly. And you, drifting into sleep, are part of its story, a quiet thread woven into the infinite cloth. Good night, traveler. May the cosmos keep you. May your dreams float among the stars. The Night Library will be here, waiting when you return.